All right, welcome back. This is episode 12 of the Duck of Doom, and wanted to get back a little bit into our to-do list here. This is just how I proposed kind of design documentation and or keeping track of the project, and I haven't been keeping it quite up to date as we should have, so let's take a look here. We had checked off this stuff early. Let's put X's here for these being checked off. And this scene is created as well. We have a 3D model of a duck. UV map is done, texture map is done, normal map is done. I purchased some sounds online that will not be shown in the series because I had to put in my credit cards and stuff. And animations are done. And then the Duck of Doom. Created the model, UV map, texture map, sounds again purchased online, animations, the shotgun, texture map. I have some sounds for this as well. And okay, so most of this is done. Scoring we haven't done, and code for gameplay logic. So we started working on this. We had a FPS controller, and we used the built-in one from Unity for that, so that was going fine. Sorry, bear with me, I got two screens here. And I try to make sure all is well on the streaming front. But my second screen's locking up because it's compiling iOS app right now, so hopefully everything's going well. Alright, so we used the FPS controller for that. And then we scripted some classes for the ducks, which we made a eye damageable interface, which lets us hit things and cause damage and kill them. Base classes for the ducks. We made a player behavior class. Now, having created these is certainly not the completion of it all. We'll be doing some of that tonight, and but as you see, item 6 we haven't touched yet, but since last time I came in here, we've completed many of these objectives, and some of these need further breaking down, like adding in features for player behavior is you know, like trigger, shotgun, animation when firing, trigger, shotgun sound when firing, reload mechanism. Let's see, player takes damage, player dies. So might need sounds for those that I don't know if I have those right now, but we can get them. And then you know, I can keep breaking things out here, but we're doing really good on our list. So let's get back to the game here. I did want to point out I left us in a place last time where I had opened this up 1 or 2 nights ago. And the problem at the time was that shooting of the ducks had stopped working. This one, if you recall, takes 5 hits. And that stopped working. So that's one reason I did not stream last night. And it turns out the player behavior script, which I somehow have 2 of, I think I reordered the camera inside the player or something and put the shotgun underneath. But at some point, the player behavior had been up here at the player object, and then it turns out that it needed to be on the main camera, otherwise the ray casting wasn't working correctly. So, alright, oh, that iOS app is trying to build here. So that's just a tip. If you were following along, and if you're having ray casting problems, that needs to go there. That can be solved in other ways, but just that's the easiest way to do it. We could make a reference specifically to the camera, and I guess I'll be honest, recasting is not my expertise as of yet. As you saw, I referred to documentation last time. I'm not sure why that mattered. There is a kind of line of sight kind of casting from a camera that you'll see in the documentation, but I didn't think we were using that. So I'm just a little surprised that was a problem for us. So again, let's just kind of take a look at what's happening right now. So, we can go along, I can run, and this is just a little plane I have here. And these ducks, believe it or not, they're actually gigantic. Oh no, I jumped off the world. I'm gonna shoot the duck. Die. Oh, and I can't get my angle where I need to be. Yeah, sucker. All right. So that's kind of some of the basic gameplay. What do we want to do next? I guess let's try to trigger the shotgun animation, because that'll make it look more realistic. So the way that works is on the shotgun, there is an animation, and we want it to play this fire sequence, right? So we can do a private animation, and on the startup method, here's where we finally get to use that. Why is that not happy? Did I spell animation wrong? Sure did. Okay, so on the startup, it'll assign this private member variable animation. It'll search the game object and all its children for the first animation component it finds. If it so happened that there was more than one of those components, then that would be a problem. And I see I inadvertently deleted the closing brace there. So if we are firing the shotgun, let's we can do it one or two ways. We could make a method that says call the animate shotgun, and in that method it would call the actual animation. That would be appropriate if multiple things could call it. In this game so far, the only thing that's going to call it is when you press the left mouse button. So we're just going to directly use the animation dot play, and then it should be Unity does it by the string. So let's save that and go look at the name again. It's fire with a capital F, and case sensitivity does matter. All right. Let it compile and build here. And then if I've done everything right, when I pull the trigger, bam. Oh, it's looping, fun. Boom, boom, boom. All right, let's fix that. Fire, loop, default. The default wrap mode should be once. Yep, so it's firing once for each one. Might be a little slow, so let's we can actually adjust that in the animation properties. I thought we could. Can I do this? I think that might not actually play all the frames, but let's see what happens. Yeah, I didn't play all the frames. All right, play all the frames. And what I think it is that if I were using an animation controller, I could set the speed, but I'm not using, just using legacy animation. That's probably where I was thinking that other thing from. So next we can try to make it fire a sound. So I like to use, and you know, Unity sound system has fairly direct ways of doing this, and I guess I could or should do that. Let's see here, adjusting that iOS build again. So 3D play sound 3D. All right, so plays the clip, so we probably need an audio clip and the audio source. Yeah, I mean, all this is fine. This is what you would use, the API methods for Unity's built-in stuff. But just so you get some exposure to different things, I'm going to go to the asset store and import an asset that I really enjoy called Master Audio. And Master Audio has a couple of features that you could certainly program yourself. Yeah, well, we redid the store. Look at that. Impressive new assets. You know what I'll be impressed by is if the asset store doesn't run like crap, like pretty much all the time. Yeah, that's all right. Contacting asset store. Apology, I have no idea. Here we go. All right, so yes, I have purchased way too many assets. Oh, look at that! I found that way faster. Okay, thumbs up. Like, used to be like nightmare to try to like search, filter, and find stupid stuff. All right. We're going to import Master Audio, just import. So I'm a thrifty individual, and what I like to do is watch for these things to go on sale. So certainly you can do their little thingy dingy if you buy a lot of stuff, and I do, so maybe I should have done that. But if you just keep an eye on it, you will find that you can get it on sale over the next 3 months. Usually it goes on sale frequently enough, but if it's well worth the money if you happen to be in your budget. It's not really that expensive. All right, so now that that's imported, should be able to go. I don't really need all this. Master Audio, and then let's see. Okay, and we want to create their prefab in the scene, and hopefully I did not just create that as a child of my player object, because that's not desired. All right. And the playlist controller, I don't know if we'll end up needing that, but just in case, that's for like music. All right, so then in here, drag an audio clip in here, and it'll do its kind of dirty deeds. So I have my media folder. Remember I said I went and purchased some sounds. So another asset I bought is called a Universal Sound Effects Kit on the asset store. It's got like 3,000 sounds, and those are all pretty reasonable sounds. I wouldn't say they're AAA quality or anything, but they're very serviceable, and for the price, can't beat it. So there's bird flapping the wings, ducks quacking. All right, enough. clearly I need to edit that sound. And then here's the universal sound effects one. I have this. It's 3,000 sounds, so I literally offline I went and trimmed out what I think I'm going to need for this, which is still maybe I brought in too much, but I don't need all these. Let's preview some of these. Man, those sound so similar to me. That sounds different. Why are those first three so similar? Is it literally the same sound? Model 01, fire single, R1, R2, R3. Okay. It says they're different. And I guess if you look at the waveform, it is marginally different. Let's see if these ones sound different. I can't even tell the difference. That's different. All right. So let's go back to here, and we'll go. So here's a trick here. We're going to go bring in the first one, and then we're going to go into here and say firearm, shotgun, blah blah blah. We'll go shotgun, fire, and then so we can do some variations to create variations. So we started with 01. We're going to do 01B. 02, 03, 04. So this is one of the nice little features I was telling you about Master Audio. So the variation sequence up here is randomized or top to bottom, so it would cycle through. I think cycling through is just too predictable, so we'll go through with randomized. And if we wanted, we can go in here. Sorry, my throat's dry. Go through in here and tell it to change the volume, the pitch, and or apply a random pitch. So like make it a tiny bit higher or lower pitched. In the case that I have 4 separate distinct sounds, that's not quite as necessary. But if you ever have a sound that you only have like 1 or 2 and you need it to sound not quite as repetitive, you can use some of these things like a randomized volume. Just the sound being a tiny bit louder or a tiny bit softer makes it sound different. So it's cool little features. All right, let me make a prefab out of this Master Audio dude. So now when I go to fire my shotgun, oops. The string, okay, the transform. So, you know, I don't need this because it's going to be from the player's perspective, so I don't need it. For like the ducks, we'll end up doing the 3D sounds because the ducks could be at different positions. But from the shotgun, it's always from your perspective, so that should be good enough. All right. Surprise, surprise. Is it possible I did everything right on the first try? Probably not. Look at that. Hopefully you could hear that come through, but each time I fired, it made a different sound. And what was interesting is it was all in the right channel, my right ear. I don't know what you heard, so let's see if that matters, if that helps, because I want it to be in both ears, or yeah. Oh yeah, much better. Okay, perfect. I like that. All right, so now we have some fire and shotgun, and so the next thing we can do, if we so desire, and yes I do, is make a particle effect that looks like there's you know, firearm firing. So sorry, particles, where are you? Sprite, no, effects, here we go, particle system. All right, So particles, again, there's a library I used to like called Particle Playground. It was fantastic, but the guy stopped maintaining it, and it is now deprecated, and it's got a couple of small bugs. It was as useful as Master Audio was, just for particle systems, but I'm very sad the dude stopped doing it. Very sad. All right, so let's put that right at the end of the shotgun, and then let's go the emission. What we need to find is the shape. Okay, a cone, donut box, mesh, skin, circle, edge, hemisphere. Sphere, no, definitely not. Cone, yeah, cone's okay, but we just want it to face the other way. Although, like these sprites. Okay, good. And then duration, no, definitely not 5 seconds. And it's definitely not going to loop. Although, it can be okay to loop while we're designing it. Start speed. I don't know. So, with the color, so all these parameters, it's very hard to say. Really, we just want it to look like a flash, right? And this is where I'm weak because I've been using the particle playground a lot. Will it fire right as we go here? Yeah. Okay. Yeah, that's not what we want. It's like sparkle dust. Very neat looking, but not shotgun. Okay. It's funny, I told it to not to go ahead and loop for now, and it's not doing it. So here's another setting, like max particles starting at 1,000. I don't really know why they put it at that. That's often too much for a lot of games. Man, I'm just gonna completely fall on my face here. Alright, we got the cone, angle, radius, so maybe I want to change. Can we see the widget? Here's the widget. Alright, from base, I mean, that seems fine. Velocity over lifetime, no. I mean, it could get faster over lifetime, okay. So, I guess let's bump that up, because it's not showing us anything. Come on, you can play, simulate. Billboard should be fine. Default particle. I don't think I have any others. Yeah. Should be fine. Why don't I see it? Blah. There's a 2-second example. I think the size needs to be bigger so it looks like a burst. Kind of too big. Start lifetime 0.5 at max, maybe less. Start size, let's go just straight up 2. Okay, what's happening is it's moving to the left for some reason, probably to do with emit from the base scale. Alright, well what I need to do clearly is go re-educate myself on the Unity's particle system, so we will save that for another time. I will go watch some videos and we'll get back to that. So let's use Audacity. So in the apps that I covered, we talked about the original apps that I might use in this, and Audacity is one of them. This is an open source free application. I highly recommend it. So let's go, the duck sound was way too much. So as you see, there's like 1, 2, 3, 4, 5, 6, just like a dozen. This is really interesting. The duck audio waveform of a duck quacking looks like a duck. That is hilarious. That is amazing. That's okay. Alright, so in any case, so I'm gonna zoom in on this a bit, and when you're doing a sound, what you want to do is grab it just a heartbeat before and a little bit after. I'm gonna copy, file new, and then we'll zoom in again, and then to avoid sounds popping, what you typically want to do is grab the last little bit, especially if there's any excessive like if this was the end of the sound, it would be a bigger problem. Here we see it tapers off to quietness, but just to be really careful, we could go effect, fade out, and that makes sure that when we play it, and here I'm going to play it looped next, there's no popping. That's the last thing you want. So now I'm going to export this, and that's one of my other games. So duck quack 1. Okay. So I'm gonna make maybe 4 of these. So just looped that as a test. There was no popping, so it's good enough. If it did pop, then we would do the fade out trick instead. And the reason I'm zooming in is you don't want any excessive amount of time before or after the actual usable bit of the clip, so that you can play it as often as you needed, and it doesn't occupy too much of the audio channels on the device. Especially like in mobile devices, it's a big deal. There's only so many audio channels, so if there's a large amount of silence at the end, then it keeps playing even though you can't hear it, and it's occupying memory and an audio channel. Oops, play it looped. No popping. Let's export. back to master audio, and we're gonna bring in duck quack 1, and then under here we'll call it just quack. And now we're gonna bring in the variations. Okay. Apply the prefab. Now under ducks, I'm gonna bring in okay, and then I guess the question is, when is he gonna quack? There should be an interval that they quack, but only when they're active. And we haven't scripted a lot of their behavior yet, of flying around and whatnot. Let me think about this. 1 second, the iOS app wants attention again. Apparently I don't know what I'm doing there. Okay. So, let's see, what time is it? Is it time to program in some duck behavior? I guess let's just do something silly so we can hear him quacking. So, private float duck quack timer. So we're going to make them quack every 5 seconds, at least the first time. And then update if duck quack timer is less than time.time. Master audio dot play 3D. That, yeah, okay. So what this means, it'll play it at the sound quack at this transform at full volume. Which I wonder, can I leave off the volume, because maybe it'll decide for me the volume based. Yeah, let's do that instead. So, and then once that's been done, we want to immediately take the duck quack timer equals time.time plus random.range to F 5F. So between 2 to 5 seconds. See if that works. There's the 5 second mark, and yep, about 3, 4, okay. Yep, it's working. Now let's kill the duck. Alright, duck is dead, and he should stop quacking. Very nice. Alright. So good enough. Now let's copy that code to the duck of doom. Again, I could make some reusable duck code in the bits that are the similar, almost the same code right now. The duck of doom will become more specialized over time, but there's no reason they couldn't both have actually the exact same script, but just a couple of small booleans that separate them. Just doing this for now. Oh, what is my error? I have an error somewhere. It's probably in stupid master audio. Huh? Yep, it sure is. Let's see what JetBrains Writer thinks is an error in master audio. Unity Engine serialized field is not valid on this declaration type. It is valid on field declarations only. So master audio appears to be working, so I am not going to try to fix that for them. Hopefully they'll just update and fix that, but it seems to be working, so good enough, right? So now when I press play, both the ducks should quack at the 5-second mark, and then thereafter they should both randomly be quacking every 3 to 5 seconds. There's the 2 quacks. Yeah. Cool. All right. Very nice. So let's consider if this is a shooting gallery, which, you know, we haven't designed out what the actual gameplay is going to be like, but let's use Photoshop. All right, so some drawing tools here. All right, so if the player is standing, pencil tool, brush tools, fine. Player's here, and here's a shotgun, and here's ducks flying around, right? So can have them standing in this kind of staged area. They can't see the stage, but ducks will be flying by from left to right like this. And what we may want is that some will start at various heights, and that they're going to go either low, or I guess in this case going high would be kind of a bad move. So maybe what they'll do is they'll decide, okay, I'm going to spawn at one of either a left or a right, and then I'm going to choose one of the other spawns on the opposite side. So I'm going to start here, and then I say, well, do I want 1, 2, 3, or 4 to go to? So it randoms which one it's going to go to. Oh, I'm going to go to 3, so it's going to go straight. Oh, no, it was going to go to 1. So that's one way to do it. Another way to do it might be to say, okay, I'm going to spawn at any one of these, and then there might be an array. Let's trim some of this out real quick. There might be just random little bits in here. So here's one, here's one, here's one, here's one, here's one. So all these little game objects that I put in the scene, and it spawns, say at point 3, and it is aware that all these are possible destinations and just picks, okay, I'm going to pick this one. Then as soon as it gets there, it picks the next one, the next one, the next one. And it just has to keep picking, but it can't be the one that it was already on. So boom, 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 boom. And then after 4, it's going to fly off the screen, for example. So you see, that creates a situation where the duck would be a little bit more kind of, it looks like it's dodging or whatever. But a little more challenging to shoot too, especially depending on its speed and whatnot. Whereas if they were just going all the way across, that becomes a lot easier for the player to shoot. And I think it's fair for there to be a reasonable amount of challenge for the player. So these are all game objects. So these will be spawn pool objects, and these will be flight point objects, right? So that's one way we could handle it. And this works well if we're doing the shooting gallery thing. So that's something you could plot out on paper, or you could do here I did in Photoshop, or you could figure it out in Unity. But the point is that I used kind of a concrete tool to get an idea, because now when I go to program it, I have a concrete implementation in mind rather than like literally no idea what I should be doing. And that's a good recipe for just getting stuck and not knowing what to do. You know, again, I like calling these little things game objects or not. You don't even have to have conceptualized that. You're just thinking, well, how would this enemy decide to get around, right? So you saw my thought process here. I find people get stuck on, especially what they consider to be AI. Well, we just designed an AI here at a high level, of course. Okay, we aren't going to play with that. So let's go make some of those points. Now we need to identify the player's field of view a little better, and I think we did say that the player kind of maybe doesn't want that thing over there interfering with the ray casting, if indeed that was even the problem back when. Okay, so the reason I'm sizing this at the moment, I'll change it later, but what I want to have a good perception of is, does this cover from left to right for the most part what the player is likely to be able to see? And the answer is mostly. Okay, this, yeah, all right, it's fully off the screen. And then I'm just going to make it a little bit bigger just for fun. All right. So now these 2 points are the extents of where we want empty game objects. Create empty. Okay. So duck left spawn 01. Okay, and then 1, 2, 3, 4. Okay, and now I'm gonna copy that. Put over here, duck right spawn. 1, 2, 3, 4. Okay. Okay. 1, 2, 3, 4. And then finally, the grid of navigation points. Duck nav. So this will make it easier for me, the isometric view. So I want them to start here. I'm just gonna copy and paste a bunch of these. Okay. And then to make this a little cleaner, I'll do all the duck left spawns under the first left spawn, all the duck right spawns under the first duck right spawn, and all the duck nav points under there. Okay, so now it's not as messy. So now we need our first kind of manager kind of system to manage the duck entities. So let's go and create a new script. So, player UI. So let's create a C# script. We'll call it enemy manager. And we'll put it on the game controller because in Unity, for this to work in the scene, it's got to be on a game object. And then so we can edit the script. object, and it's going to be an array of game objects of left spawns. And then you know what's coming, right spawns, and escape, and this is nav points. And I think, forget, I might have to mark those as like public serialized fields for them to show up here. We'll see if they come up, and nope, they came up just fine. All right, so the size of this is there's going to be 4 of them. The size of this is going to be 4 of them, and then I'll count the other one. I think it was 13. So let's expand these. Game controller, if you click the lock icon up here, then I can click on other stuff and it won't disappear. So left spawns. 1, 2, 3, 4. Right spawns. 1, 2, 3, 4. Okay, nav points. 15. There's actually 16 then. Because this one says 1. This one is 1, copy 1, so that's why it's 16. Okay, good. So collapse those back down. So now let's go make sure we turn off the lock. Let's make sure we fully applied the Duck of Doom and the regular duck. Although, actually no, I want to make them smaller because they're freaking gigantic right now. So I guess let's do 0.025. What I need to do is bring that in closer to the player and see if that actually is a good size or not. See, they were so far away, but they were so huge that they still even looked big in the sky because they were just gigantic scale. Alright, they're still pretty big. Okay, I think those are more reasonable sized. Alright, so those are prefabs, so we're going to delete them from the scene. And then in our script here, going to game object duck, public game object duck of doom. And the reason those are public, of course, is so that we may place a public reference to them on our script. There we go. Duck of doom and regular duck. So then on start, we want to just go ahead and guess what we need helper methods for determining spawn points and for determining flight nav points. Although actually, let's have the ducks. Yeah, the ducks should pick their own flight paths. So the enemy manager will just pick the spawn points. So int public int num ducks to spawn. And I'm not going to put a initialized number here because I just want it to be in the inspector. So object d for duck equals instantiate the original, which would be a duck, at transform. Let's just do this. Transform in quaternion identity for now. I think that is. We don't have a missing. The vector is 3, so the transform dot position, is that what it wants? Yeah, alright. Sorry, I always forget this syntax here. So this is generally the code that would spawn the duck, right? So if we can prove that by going over here and let it compile, and somewhere it should just spawn a duck in the scene. Can hear him. Where's he at? It's probably down below or so. No, I'm following. Duck, where are you, duck? Alright, pause. Where's the duck? Player duck left, duck right, duck. No, duck prefab clone. There he is. He's at 579, 191, negative 825. So he, yeah, it did spawn a duck. That is the code we needed. Alright, so, but instead what we want is, void spawn duck. Okay. So we're going to build this parameter list. So the game object. So geo, okay. And then the vector 3 location, and then the, I think the quaternion will just always have what it is. The quaternion is the rotation. And I apologize, I'm thinking this out, half out loud, half in my head. I will explain it just a little bit more as I implement it here. All right, so it's going to start up, and then for however many ducks we tell it to spawn, it's going to call the spawn duck method, and we will tell it which prefab to do and where it's going to go. The where of it is going to be either a left spawn or a right spawn. So let's pseudocode that out. So, startup, spawn, the number of ducks to spawn at right or left spawns. So, okay. For each, var is num ducks to spawn, or wait, I'm doing it wrong. For int I equals 0, is less than numducks to spawn. Man, something about live streaming kills my brain. There we go. Alright, so we're going to initialize at 0. And then while the number is less than whatever the total number desired, so let's say we set it to 4. So while that's less than 4, then spawn a duck. And so then we need to do either regular ducks or ducks of doom. In this case, we're going to do a regular duck. So then this becomes the game object we passed in. The transform position becomes the location we're going to pass in. So then here we need to give it a location, right? So get random spawn location. And see, that doesn't exist, so we need to make it. So private, and this is a vector 3, it will return. The reason it's red is because we haven't returned the required vector 3. So I'm going to go random, or what we need to do is choose randomly between left and right spawns. So we can go if random dot range 1 to 100 is less than 50. So 50-50 chance, right? Could do 1 to 2, but I like thinking in terms of 1 to 100. Spawn left, else spawn right. Okay. So we say vector 3 equals spawn loc. We'll fix that in a second, although alright, so now we just need to figure out a way to choose one of the left spawns or one of the right spawns. So the method should be pretty much the similar. If we work it out once, it might be that we can reuse the method, so extract a method, but let's just work it out. So the left spawns, I'm doing this to make it more demonstrable. Count or length, oh, okay. Is that right? Good. So in an array, it's 0 indexed. So it means the first one is at location 0, the next one is at location 1, 2, 3, and so on. If there's 4, it would be 0, 1, 2, 3. So we know there is 4. But the reason we're doing this, getting the length of, is that what if I decide for some reason that it needs to be 6 or 2? Then I don't have to rewrite this code. So I'm going to do, I have to randomly pick one. So we've got the count, and then int item to pick equals random dot range 0, starting number, count is the ending number. And I believe in random range that the returns a random integer number between the minimum inclusive and max exclusive. So what this is saying is if the length is 4, so the count is 4, that and this is a little confusing, the maximum number that could appear here, so let's just make this clear. 4 is the max, right? So this will only ever return 3. And if you remember what I was just saying, 0, 1, 2, 3. That's a 4-item array. So that's perfect. So that's why you have to understand what that documentation is right there. Max is exclusive. So whatever the maximum number, it'll always be 1 less than that. So this is exactly what we want. So we say the spawn loc equals left spawns item to pick. What dot? It should be a vector 3, but no, it's a game object. Yeah, so the transform should be a vector. So transform dot position. There we go. Sorry, I had to think that out. Okay. So we can compress this code a little bit, but I wanted to kind of talk it out and help you see what we're doing. So this is how many spawn points there are. So we can actually replace this here. We don't need this whole line anymore. And then, so what we're going to do is put the result of all this in this variable. So then we can just take all this and put it right here, and we don't need this code anymore. Right? And so then this can copy to down here, and we just change it to the right spawns, and now I think that has a chance of working. Five ducks. Let's see what happens. 1, 2, 3, 4. There might be 5. 1, 2, 3, 4, 5. Yeah, one of them's just where we can't see. Sorry, my mouse is going off screen. No, I fell again. Oh my gosh. Stop it. 1, 2, 3, 4. Where is the 5th duck? Is it lower or higher? Stop. No, wow. It's like ice. I'm just trying to see where the 5th duck is going to. 1, 2, 3, 4. Look at that. It was overlapping. Okay. So the overlapping thing is okay. If we go back to here, there's a couple things we can think about. Firstly, what's the chance that if 2 spawn on point 3, on top of each other, what's the chance that, when we do the next bit of code, that they're both going to go here? Well, it should be 1 in whatever amount of items there are. So if there's, 16, then the chance should be 1 in 16 that they're both going to go to that exact same spot. And that's pretty low, maybe acceptably low. But what also could be done is there could be a short delay here, and we could put this in like a coroutine where it actually spawns these guys over 1/4 second intervals or something like that. So even if there were 2 ducks and they both spawned at the same point, and they both spawned with the intent to go to the same first target, that they would be a quarter second behind each other, and then that should fix that. So in any case, though, I think we're going to design some of that out in the next episode or two. But I feel really good. We have ducks spawning. We'll get them flying soon. We have shotgun sounds. We have quacking sounds. So things are coming together. It's starting to feel good. Thank you for joining me, and we will see you next time.